So in this module, we're going to look at green roofs and do that project in lab. So this is our chance to familiarize ourselves with some of the issues so that it can help enhance our project in lab. So obviously green roofs are going to be a go-to choice for many of your design projects. They add a whole lot of features to our built environment. They have a great aesthetic, obviously. They help us manage stormwater. They create cooler surfaces as opposed to reflective or roof surfaces that aren't reflective. And so that manages heat island issues. They preserve the longevity of our roofs by protecting the rubber membrane from UV exposure. They provide habitat and biodiversity depending on how they're planted and what kinds of other insects and birds they might support. Um, Obviously improving air quality and noise reduction by the fact that they are sound absorbing surfaces. And so that's just a brief list to get us in the mode of thinking about their positive aspects. But there are obviously these issues of design aspects. So I've included some slides from this Green Roof Design and Construction Manual. It's from 2009, but I think it's pretty up to date, so to speak. Obviously, a cross-sectional roof to just get us started. We have our vegetation, our growing medium soil, and or other kinds of amended soils. We have a opportunity to manage what is placed in the soil composition to affect roof weight and moisture absorption. We have a drainage layer and filter fabric. Sometimes we have a root barrier, maybe always we have a root barrier to prevent vegetation from damaging the waterproof membrane of the roof, and then the structural deck. Luckily, we're guided by codes, so we have guides to making sure we create safe and high-performing systems. So here we have engineering standards for a whole host of things. These are actually assembled standards that we bring together when we're talking about the construction of green roofs. Obviously, loads, dead loads, and live loads go for roofs that don't have vegetation on them, but these are the standards that we would concern ourselves with. And then the building code gets into some specifics about issues when we talk about green roofs. And we make a really early distinction between this idea of them being occupied or not occupied. And that affects ideas of safety and loading. The designer has a host of choices with green roofs. This is constantly changing and evolving. The idea of the intensity of what you're growing, whether people are going to be, how accessible it'll be for people, how much it'll weigh and all of the structure that goes along with it, how much maintenance it will need, and obviously all of these kind of design decisions affect overall cost of roofing systems. So one of the first things we need to do is concern ourselves with the idea of the added dead load of the applied system. So in a commercial deck system, we have 60 pounds of live load to work with. We're going to amend that with a dead load that's already going to take up capacity. So we need to increase structure. And if we're thinking about live loads of occupancy, we need to accommodate that also. So kind of the ideas of the process of, once again, of design decisions. What kind of roof do we want to have? Is it going to be occupied or not? And then how much occupancy? So obviously one of the first issues about this idea of occupancy is if it's occupied by the general public and or an open space or an extension of an exterior space, we need to worry about fall protection just as we would on any other elevated surface. And these systems can become first an aesthetic issue for us. What do they look like? And they can be quite expensive. So this is a significant cost when we talk about occupying it. Also, if we're occupying it, we're making a concept about how heavily it's occupied. So if it's used as a deck system, an outdoor entertainment area, the live loads can be quite significantly in addition to other loads that might happen on the building. And then this idea of access and safety doesn't just extend to them being occupied. We still have to think about getting up to do maintenance, ladder access, fall protection for anyone that might be working on a green roof. And that might be not roofing people, but landscaping people. These applied loads are a little bit different than we would consider in other kinds of construction because the idea that we're adding significant mass at the roof level, um, typically a little unusual in that condition. So we have this potential for additional lateral loads through the building. We have a top-heavy type of structure, so we need to possibly look at additional shear capacity within our roof system. Um, and our vertical loads are significant because of the issue of deflections and the migration of water in our roof system. So here we have both of those in kind of the failure mode. So we're looking at a drainage failure where we've deflected the roof, and we may not have a roof drain where it's deflecting, so we're ponding water. We're actually increasing roof load and causing the roof to deflect more, even possibly to the point of failure. And in this case, lateral top-heavy building with little shear support, the possibility for lateral failure of the building. This idea of drainage, we, 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 we will not be able to absorb all of the water that falls on the roof in any one event into the vegetation. So we need to collect water just as we would on a normal roof. And we have to now consider how that roof drain functions once we've added soil and vegetation to the top of it. So we have a roof membrane that is many inches below the surface, the vegetation surface. So we need to have some consideration for the detailing and the construction of what happens around that drain detail. So this is actually probably a pretty normal detail here of a roof drain with this to screen out for blockages. But now we have the addition of an aggregate material to allow drainage through, increasing the amount of collection area. And many times we want to increase this collection area because of the possibility of leaves or other debris clogging this drain. So once again, codes and safety fall protection, issues of the height of the building, the training of maintenance workers, all of these things affect our design decisions. One of them to consider is the possibility of extra insurance cost, whether the building's insurance takes green roofs sees them as a hazard, and whether that would affect the overall cost of a green roof. Once again, that idea of safety and fall protection. And then one we probably don't quickly think about, that's the idea of fire protection. Um, this could be considered a combustible material if it's dried out, not maintained. And then what would happen with the potential for spreading fire across the roof system now that we have a combustible material. So we need to think about the additional, maybe the additional inclusion of fire breaks, the relationships of parapetting around the border, and then also this idea of roof hatching systems and where they open up in the plane of the roof, and then protections around them of non-flammable or non-combustible materials. So that's a lot to consider. We won't need to consider all of it in our project, but going forward, as you anticipate doing a green building design, it would be very valuable to kind of review these documents to get you started on the right course.